Hello everyone, I'm Kalyani from BR Siddhartha Engineering College. So today the session is a topic of distance-based models in machine learning and a classification algorithm which belongs to the distance-based models, that is k-nearest neighbor classification. So the topics of the today's session are: what are the different distance measures we have which are used in distance-based models, and an algorithm of nearest neighbor classification. So let us first move on to the distance measures used in distance-based models. So before moving on to the different measures used for evaluating the distances, what is a definition for a distance? So if an instance space X is given to us, a distance metric is a function which is evaluated between any two instances of X. That is, it will be represented as a function which is evaluating between an instance of X with another instance of X, and the evaluated value is a distance which is a real value. And the distance, whatever we are evaluating, should satisfy the four properties. That is, if we calculate the distance between an instance of X with the same instance X, then compulsory the distance between the self instance should be 0. And the second property is, if we select any other two instances of your instance space, then the distance between those two instances is greater than 0. And the third property is, the distance metric should be symmetric. That is, if we consider any two instances X and Y, and if we calculate the distance between X and Y or the distance between Y and X, both should be the same. And the fourth property is, if we are evaluating the distance between two instances X and Z, and it should be less than the distance between X and Z by considering Y as intermediate. That is, distance between X comma Z is always less than or equal to the distance between XY plus distance between Y and Z. Then what are the different distance measures we have? So the generalized distance measure is called with the name Minkowski distance of order P. And this Minkowski distance is represented if instance space X is represented in terms of real numbers. That is, if your instance space is represented with continuous attributes, then the distance calculation can be done by using this Minkowski distance. And this Minkowski distance of order P is also be called with the name P norm distance. So the formula to evaluate the Minkowski distance between any two instances X and Y is simply the difference between X and Y. And the difference between X and Y is raised to the power P. And if these instances X and Y are expressed in terms of more than one dimension, then for every dimension, the distance will be evaluated. And finally, for all the dimensions, the differences should be summed up. Hence, the formula of Minkowski distance is sigma j is equal to 1 to d xj minus yj raised to the power of p. And to the sum of all these differences, whole to the power of 1 by p is applied. And in this formula, d is the number of dimensions of instances x and y. And this generalized distance, Minkowski distance of order p, can be represented in different ways by considering a value for p. So if we consider the value of p as 2, then it is simply called with the name Euclidean distance. Hence, the formula of Euclidean distance between two instances x and y is square root of sigma j is equal to 1 to d xj minus yj whole square. Here also d is the number of dimensions which are expressed for instances x and y. And another distance is Manhattan distance or city block distance, in which the value of p is considered as 1. That's why it is also be called with the name one norm distance, and where the formula is sigma j is equal to 1 to d mod xj minus yj. And there is another distance which is called with the name Chebyshev distance, in which among all the differences of d dimensions, the maximum value is considered. So in this case, maximum of all differences of d dimensions between x and y is considered as the Chebyshev distance. And the last one is called with the name Hamming distance, which is also be called with the name zero norm or L0 norm distance. So simply the Hamming distance counts the number of dimensions in which the instances x and y differs with each other. So hence the formula is simply sigma j is equal to 1 to d indicator function of xj is equal to yj. So the indicator function I is a Boolean function which returns either 0 or 1. So if the xj and yj are equal, then the indicator function will return 1. If both are not equal, then the indicator function will return 0. So simply the Hamming distance counts the number of dimensions in which x and y will differ. And this Hamming distance is generally used to calculate the distance between the two instances if the instances are expressed in terms of categorical attributes. So finally, if the distances, to evaluate the distances, if the instances are expressed in terms of continuous attributes, then we can go either for Euclidean distance, Manhattan or city block distance, or the third one, Chebyshev distance. If your instance space is expressed in terms of categorical attributes, then to calculate the distance between any two instances x and y, you can go for Hamming distance. So let us have an example of these distance calculations. So the question one is, find the distance between the two instances x and y which are expressed in two dimensions. So for x, 2 is one dimension and 3 is other dimension. Similarly for y, 4 is one dimension and 1 is other dimension. Means in this example, the number of dimensions are 2. So if because of the instances are expressed in terms of continuous values, I'm going for Euclidean distance, Manhattan distance, and Chebyshev distance calculations. So the first one, Euclidean distance. So if you recollect the formula, it is sigma j is equal to 1 to d xj minus yj whole square and to the whole value square root. So if we apply this formula to this example, because of I have two dimensions, the sigma is sum of two differences. So that's why the first one is first dimension difference. That is 2 minus 4 whole square plus the second dimension difference 3 minus 1 whole square to the whole sum square root. So it is square root of 2 square plus 2 square, which is square root of 8, whose value is 2.83. And the second one, Manhattan distance, in which the formula is sigma j is equal to 1 to d mod xj minus yj. So the mod is to compensate the negative number here. So that's why it is simply mod of 2 minus 4 plus mod of 3 minus 1. So which is 2 plus 2. That's why the Manhattan distance between these two instances x and y is 4. And the third one, Chebyshev distance, in which the maximum value of absolute difference will be considered. So here the differences are 2 minus 4 and 3 minus 1 and the absolute values are both are 2. So that's why it is simply max of 2 comma 2, which is the 2. So for the instances x and y which are expressed with 2 dimensions, the Euclidean distance is evaluated to 2.83, the Manhattan distance is evaluated to 4 and the Chebyshev distance is evaluated to 2. So let's go for the second question. That is, find the distance between the two instances x and y, which are expressed in terms of categorical attributes. So here I have yes and true, 2 dimensions, and here also 2 dimensions I have. So these are categorical dimensions. That's why the distance between x and y will be evaluated using Hamming distance. So if you recollect the formula of Hamming distance, simply it counts the number of dimensions in which x and y differs with each other. So if we compare the first dimension, it is yes and no. So it differs with each other. That's why because of it differs, it returns 1. And the second dimension is true and true. Because of both are equal, it returns 0. So the number of dimensions which it differs is 1. That's why the Hamming distance between these two instances is 1. Right? I hope that distance calculations are clear to all of you. So these are the another examples for practice of you. So the question 3 is again 2 instances which are of continuous attributes, and the question 4 is again distance calculation of 2 instances which are of categorical dimensions. Right. So this is all about the distance measures which are used for distance based models of machine learning. So let us recollect once. The distance is a function which is evaluated for 2 instances in the given instance space. And the distance measures we can generally use are Euclidean distance, Manhattan distance or city block distance, and the third one Chebyshev distance, the fourth one Hamming distance. So among these 4 distances, Hamming distance is preferable if your data set or instance space is expressed with categorical attributes. Euclidean distance, Manhattan distance, and a Chebyshev distance are preferable if your instance space is represented with continuous attributes. Right? Then we'll move on to the next topic, that is a classification algorithm which can also be used for regression depending on the distances, which is called with the name nearest neighbor classification. So what is nearest neighbor classification? In short, it is called as NN classification also. So it is a distance based model which belongs to the category of supervised, means label is mandatory to apply the nearest neighbor classification. And one advantage of this nearest neighbor classification is it can be used both for classification as well as for regression tasks also. If you recollect the difference between this classification and regression, classification is the task in which if your label is a string or a categorical label. Regression is the one in which if your class is a continuous attribute. And in nearest neighbor classification, a decision is made, that is the predicted label of the given instance is based on the k number of neighborhood instances in the given data set. And the main advantage of nearest neighbor classification is it is easy to implement because only 2 parameters are required from the user. One is the value of k and the other one is what distance function you have to use to implement the nearest neighbor classification. And the main drawback of nearest neighbor classification is it doesn't work well with large data set, because in nearest neighbor classification, we need to calculate the distances between the given new instance to every instance of your training data set. So if your training data set is large, calculation of distances takes a long time. That's why the time complexity will increase. That's why nearest neighbor classification is not suitable if your training data set is of large size. Then first we'll see an example for nearest neighbor classification. Then based on the process we have done for this example, we'll write an algorithm for nearest neighbor classification. So let us suppose the data set is of 10 instances which are expressed in terms of 2 dimensions and 1 class label. So here sport is the class label that is given to us. So because of here the class labels are categorical, it is a classification task. So if the same class column is in terms of continuous attribute, then you can take it as regression task. So just name is the one which is given only for the purpose. Age and gender are only the attributes. Then the test instance that is given to you is a person who is named as Angelina, and the person age is 5, who is a female. Then we need to identify what is the sport that she may prefer. So this orange color one, which is Angelina of age 5 of gender female, is the new test instance that is given to you, for which you need to predict the class label. That is whether she prefers football, cricket, or neither. Right? Then how can we predict the class label of the given test instance? By considering this training data set using nearest neighbor classification. So as we already mentioned, the nearest neighbor classification requires 2 parameters from the user. One is the value of k and the other one is the distance measure. So let us suppose we are using the distance measure here, Euclidean distance, and the value of k as 3 letters, right? So because of the distance measure is Euclidean distance, we need to calculate the distance between the given test instance Angelina with respect to each and every training instance. So now initially I am considering the first training instance, that is Ajay, age 32 and gender M. So the distance is calculated based on only dimensions, not the class label. Means we need to consider only here 32 and M. And for Angelina, it is 5 and F. So we need to calculate the distance between these two instances. So because of my gender is here categorical and my age is numerical, we are converting the gender also into numerical for Euclidean distance purpose. Otherwise, you may also convert your age into categorical, and because of gender is also be categorical, you can go with Hamming distance calculation, right? We already discussed that Hamming distance is suitable if your data set dimensions are categorical. If your data set dimensions are continuous or real values, then you can go for Euclidean distance. So because of here it is Euclidean distance, we are converting a categorical attribute into real or continuous representation. So because of gender is having only two distinct values, male and female, we are replacing with 0 and 1 all this. So that age and gender both will become the continuous attributes and we can go for Euclidean distance calculation, right? So let us calculate the Euclidean distance between, that is the given test instance with the first training instance. So the first training instance age is 32 and the gender is M. And the given test instance is age is 5 and the gender is female. So the Euclidean distance calculation between these two. Because of the given training instance gender is male, it is replaced with 1. Sorry, for given test instance it is female, so it is replaced with 1 and the male is replaced with 0. That's why the instance Ajay is 32,0 and the given test instance Angelina is 5,1. So the calculation of Euclidean distance between these two is simply 5 minus 32 whole square plus 1 minus 0 whole square. So if I simplify all this, the distance is 27.02. So it means that for the given test instance, the distance with respect to the first training instance is 27.02. So similarly, calculate the Euclidean distance between the given test instance with respect to every training instance. So if we complete all that calculations, these are the different distance measures after evaluation. So now my Euclidean distance measure calculation is over. Then based on the k value that is considered, I need to go for the next step. So because of the k value is here 3, we need to select the 3 training instances which are having minimum distance. So if you observe here in the distances, the 3 minimum distances are 10, 10 and 11. Right? That is Michael, Smith and Sarah. Because of k value is 3, I am considering 3 minimum distance training instances. And the 3 selected 3 minimum distance training instances are these 3. And the corresponding class labels in these 3 instances are 2 belongs to the cricket label and 1 belongs to the football label. So because of the majority label is cricket, we can decide that Angelina belongs to the class of cricket. So if k is considered as 3, then because of 3 minimum distance instances we are selecting, and among those 3, 2 belongs to the cricket, we are deciding that the given test instance also belongs to the cricket. So let us suppose if I consider the same example with k is equal to 5, then we need to select 5 training instances with minimum distances. And these are the 5 nearest training instances to the given test instance. And among these 5 instances, if you observe, 2 belongs to the cricket and 3 belongs to the football. Because of the majority class label is football, now in this case, we can decide that the given test instance belongs to the class of football. So means if k is equal to 3, it is decided as cricket label. And if k is equal to 5, it is decided as football. Means the predicted class label in nearest neighbor classification always depends on the k value that we have chosen. That's why the nearest neighbor classification is sensitive to the value of k. Then what is the effect of k on nearest neighbor classification? That is, if k is too small, then each and every time you may select only one. Let us suppose the too small is 1. So I will select only one training instance which is nearer to that, right? So that's why if k is too small, then the nearest neighbor classification is sensitive to noise points also. So if k is too large, then the nearest neighborhood is large, so that more number of classes will be considered, which makes your concept generalized. So in k nearest neighbor classification, k should not be too small and k should not be too large. Then what is the correct representation of the k value? So the thumb rule to select the k value is the value of k which you are selecting on your application should always be less than the square root of n, where n is the number of instances in the training data set. It means that in your training data set, if the number of instances are 10, then the value of k should be less than square root of 10. So let us square root of 10 as 3 point something. So you can select your k value which is less than or equal to 3 point something. Right? So always it is better to select the k value which is less than square root of n to have the correct representation of the predicted label for the given test instance. And the same process, whatever we have discussed for a numerical example, will represent that as an algorithm now. Then what is the input or the parameters required for KNN? That is k nearest neighbor classification is, one is the data set of n instances, and the other one is the value of k, and the next third one is what is the distance measure you are using to calculate the distances. And the output is the predicted label for the given new instance t. Then what is the procedure we applied in that example is, for each instance x in the given data set, we are calculating the distance between the x and the test instance t. That is, calculate the distance between t and x. Then we are storing all that distances along with the instance number in the training data set. That's why the second step in this one is add the distance and the index of x to the ordered collection. If once all the distance calculations are evaluated, then the next step is sort these distances in ascending order. Because based on the value of k, we need to select k minimum distances. That's why in step 2, we are sorting all the instances based on ascending order of the distances with training test instance. And in the third step, based on the value of k, pick the first k entries from the sorted order. Then after picking the k instances from the sorted order, then we need to decide the label for the given new instance t based on the label of that selected instances. That's why from the selected instances, get the labels. And based on these labels, we can predict the label for the given instance. So if your task is regression, means the selected labels are numericals, then simply consider mean of all that k labels. If your task is classification, because of your selected labels are strings or categorical, then simply mode of the k labels will be considered. So mode means the label which occurs more number of times. That is the majority. Means finally, after selecting the k instances, depending on whether your task is regression or classification, the final label will be decided. If your task is classification, majority of the label in the k labels will be selected. If your task is regression, then for all the k labels, whatever you have selected, mean will be applied and the mean value will be decided as the predicted label for the given instance t. So if we summarize all this KNN algorithm, simply the first step is calculate the distance with respect to the given test instance and each training instance. Then the step 2 is Sort the instances of the training set based on the distances in ascending order. Then the third one is based on the value that is given to you k, select the first k instances from the sorted order. After selecting the k instances, the step 4 is from those selected instances, get the k labels. Then either step 5 or step 6 will be applied depending on the task. That is classification, go for step 6. If it is regression, go for step 5. So regression makes use of mean of the k labels, and the classification makes use of mode of the k labels, that is majority label. Then finally, what are the important points that we need to remember for KNN classification is, so it takes more time if your data set is large. That's why if your data set is large and if you want to go for KNN algorithm, then compulsory you need to reduce the number of dimensions by applying some sort of dimensionality reduction techniques or feature selection techniques. Then if your data set is having noise, then definitely the value of k should be large. Because if your data set is having noise and if k value is small, then automatically the predicted label is sensitive to that noise. That's why if data set is noise, go for the large value of k. And what is the relation between the value of k and bias and variance, which are the most important in machine learning? So if the value of k is small and your bias will be small, as k increases, the bias increases. So if you recollect, bias is the difference between the actual value and the predicted label. So if k is small, bias is small. As k increases, bias also increases. Then if we consider the second term, variance. So variance indicates the variation in the data set on the prediction. So, and it is always the inverse proportional to bias. That's why as k decreases, the variance increases. That is, if k is small, bias is less and variance is small. That's why k should not be too small and k should not be too large also. Right? So if you recollect, the thumb rule to select the k value is k is always less than the square root of n, where n is the number of samples in the given training data set. So this is the distance-based models of machine learning and the most important classification algorithm in that, which is k nearest neighbor classification algorithm. So thank you.